So doing this table of value, what can you tell me? Yeah. What can you tell me about what you just see? So, do you notice any similarities? Which one coming in the same? So if you're looking at the first two right here, they're giving you the same answer. If you look at these, they give you the same answer. No matter what the triangle is, as long as you have the same angle, right, it's giving you the same ratio, right? At least close, 0.78, 0.7986, that's close to 0.8, right? Yeah?
Yeah.
And then the opposite over adjacent is giving you the same ratio for tan, right? So if you look at this, this tells you that if you have the same triangle, right? And then you do the ratio of the opposite of the hypotenuse, even if your answers are different, the 3 and the 4, right? Even if they're different, you have an angle of 37, it's going to give you the same ratio for sine. Okay? You see how this was 3, this was 5, right? And this is 9 and this is 15. They have the same angle of interest, which is 37. If I do that, it's going to give me the same answer. Okay? So, this brings us to the formulas. Okay? The formula says that sine the angle, so sine angle A is opposite over hypotenuse. Cosine angle A is adjacent over hypotenuse, or otherwise simplified as CAH, C-A-H, right? Tangent is opposite over adjacent. So this is where they got SOHCAHTOA acronym from. Right? So is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tan is opposite over adjacent. Okay? Are you okay with this? All right. So trigonometric ratio can be used to calculate a side of a right triangle if an angle and a side are known. So let's look at this. So you know an angle, you know a side, you're looking for this side, x. This is already labeled for you. 65 degrees. Where's the hypotenuse?
X.
X is the hypotenuse. What is 15 with respect to 65?
Opposite.
Opposite, because it's side across from it,
Mm-hmm.
right? So which ratio includes the opposite and the hypotenuse? Sine. So I can say that sine the angle, which is 65, always sine, cosine, and tan, they are accompanied by an angle, either a letter angle or by a value angle. Okay? So sine 65 equals to, what's the opposite? 15 over the hypotenuse, which is x.
So we do cross multiply, right?
Okay? What?
We're supposed to cross multiply? Is this the one?
Cross multiply?
Yeah.
If you cross multiply, then it will be x times sine 65. Would I be done? No. I have to do one more step. What is it?
I knew that to do something.
So sometimes it's easy if x is in the numerator, then you cross multiply and then you'll be done. Okay? But in this case, If I do that, if I bring the x over, it becomes x times sine 65 equals to 15. How can you solve for x? What do you have to do? Bring sine over, it becomes a what? Division, right? So I bring that sine over here, and it becomes division by sine 65. Okay? I always look into this. I usually don't write that middle step. Can I show you something here? You see these two? They switch. So whatever you're looking for is in the denominator, you can switch their spot.
So, which you usually skip the x side?
I usually skip that middle term, yeah, middle. But you don't have to skip it. Okay? If you don't remember it, just do the multiplication, cross multiplication, and bring the sine 65. Okay? What would your answer be? What is it? This is the side, so to the 1 decimal place.
So 16.5?
16.6.
6.
You have to round up, right? Because what's after the 5?
Yeah, 6.
Okay? And we're expecting the side to be bigger because it's a hypotenuse, and the hypotenuse is the biggest side in a triangle. Okay? Alright. So, this, if you're looking for the denominator, you have to switch. Okay? If you're looking for the numerator, you just do cross multiply. Okay? Alright. So what I want you to do is I want you to do the next two questions.